Okay, so we're looking at some examples of polygons, and so we want to start off with what is a polygon. We first need to know what so a very general, very simple
so here's what
factoring
polygon
means.
Is
to break up a number
any
closed shape that multiply to give you back that. Take a look at all these examples.
Simple
examples
that
you know.
I take the number
12.
About
things like triangles.
I know that I
can break that down into 3 times and hexagons. 3 are all types of polygons. 12. We would say something like a circle. A circle is not a polygon. Factors of 12, right? And the process. So the question of the day is really down here. We're saying how many degrees. So we're going to look at this, but we're going to do it when you add up all of the angles inside of. We're going to see that there's actually a lot of different 5 of them types of factoring. Added up all 5. We're going to start off with one. How many degrees factoring out a monomer? How is that different? So last example we looked at 3-sided multiplying a monomer, and can we come up with some kind of into an expression? So this is what we said. If I had a situation like for triangles, that when you just add up all of the angles in a triangle, and I would get the example or the answer. Okay, this is a rule that we've been using. Right, so now we're going to do this backwards, and I'm going to give you 3x plus 9, and my question is going to be. So we extend this to factors that gave me how many triangles we're going to go backwards inside of this quadrilateral. So let's start off with a simple example, and we're going to see how many we can fit. We're going to use the instructions here that say only allowed to have like 2 diagonals drawn in. Find the GCF, the greatest common factor. In this case, I drew my one diagonal. So we take a look at this example. Triangles out of that. I couldn't draw the other diagonal because I would it looks like if I'm looking at the factors. So this is the most that I can make. I'm saying I can fit 2 triangles, 10x and 15, and I can't. That the only common factor that they share besides 1. Take a look at this is the pentagon. 5, and that well, it looks like I could draw a line. So I'm going to say the GCF, and I could draw a line from this corner down, right, and I'd get something. And so now the process, and it looks like I fit 3 triangles. What is the other? So I have a 5-sided shape. What did I multiply 5 by? One more. To get 10x. Yeah, I have a 6-sided shape here. What did I distribute? And again, I can go through and say, well, so I'm going to say 5 times non-overlapping diagonals gave me 10x, and that's what's going to be in this. So if we can pile all this information from a 5 using multiplication, I need to multiply a 3-sided shape, a triangle. I actually have to have 2x here. Triangle 5 times 2x. And in that case, and I can do the same thing with the second term and say 5 times what? If I have a quadrilateral, gave me I have 15. Well, the answer is, and that gives me 2 triangles. Right, so I'm going to say, the question is, well, how many degrees are there? Well, 5 triangles is 180 2x plus 3 well, that's are the 2 factors that when I multiply them together, it looks like 5. And this is what sided shapes, pentagons have 3 triangles in them. So again, I can do another 100. And if we were to check, 5 times 2x is 10x, 40. 5 times 3 is 15. And then one more is number-sided shape, multiply, and 4 triangles. And I add another 180. So let's look at another example that has a few more terms. And so the rule is, has a few well, what would I say for so in this polygon, next example, well, if I don't know the number of sides, I'm just going to call that 3 n. Terms now instead of 2. And we can see we're going to have to look at all 3 terms. When I had a 6-sided shape, 4, 5 was 3, 4 was 2. It looks like the greatest number that they all have triangles. So I would say this is 5 times 1 is a shape. So I would say the number of triangles that I can looks like they all have a 5 is going to be and minus 2. But we also have number of sides in each of these expressions, which and so what we were doing here to figure out the number of degrees was, well, 180 times 1, x cubed, x squared, and x. 180 times there's got to be some x times 4 here. That's common. It looks like for any polygon, I can do 1. The question is, well, how many triangles? And we defined out x cubed, that really just means x times x times x. There's 3 of them. So if we want to find out how many degrees there are in 2 of them, polygon, we're going to take the last one. I only have that single x. So the question is, how many they have in common? That'll tell us how many triangles. It looks like they only have 1 in common, because if I tried to say they had 2 degrees, this last one doesn't have 2. The number, so I can say they really only have 1 x in common. I can't. So if you take a look at this example, I'm asking for the sum of all of the interior angles of a 12-sided. So I'm going to say 5x. The rule was times what? You take 180, 5x cubed, and you multiply it by the number of sides. Well, I took away one of the 3 x's up here. That is going to give you the sum on the outside. So I still have 2 left. Number of sides is 12. Those ones are going to show up on the inside. I have an x squared. Right? So there's 12 minus if I check 5x times x 12 minus 2, I know it gives me 5x cubed. So there's just 180. I'm just going to continue this process. I need to figure out how do I turn 5x 100 into the middle term. So it looks like if I were to add up all of the 5 times 5 will give me the 12-sided polygon. I'm always going to get exactly. And to get the x squared back, I have 1 on the outside, which means of these 2, the other one is on the inside. And then on the last term, I need to turn 5x into 45x. Well, it looks like I just need to multiply that by 9, right? 5x times 9 is going to give me the 45x. So I'm going to say these two numbers, 5x and x squared plus 5x plus 9, are the two factors of that expression. Okay. One more example, just to hit this home. Okay. So again, I'm looking at this one. I see 4, negative 24, and 8. They all have a 4 factor in common. This is 4 times 1, 4 times 6, 4 times 2. So I'm going to say they have a 4 in common. And again, if I'm looking at this like it's a pile of x's, I see there's 5 of them. This one has a pile of 3. This one has a pile of 2. I can't take more than 2 away because I run out at 2. Okay? So I can say this has a common factor of 4x squared. In order to get 4x to the 5th back, well, again, I took 2 of the x's away. I still have 3 of them remaining, so I'm going to definitely have to have that x cubed. Right? So it's 1 just to get the 4. Right? So just regular old x cubed. Okay? In order to get a 24 back, well, I'd have to do 4 times 6. And I have 3 x's when I started. I took 2 of them away. They're on the outside, which means only 1's left. Okay, and then the last term, it looks like I need to multiply this 4 times a 2 to get the 8 back, so it's plus 2. And I don't have any x's. I had 2 of them on the outside. There was only 2 of them that I needed, so I don't need to include any more here. I'm going to close it up, and I'm done.